Good morning. We are here to present our project titled Connects, the smart platform which connects people and household service providers. Going to the introduction, today's urban and semi-urban environments, people frequently require home maintenance services like electrical work, plumbing and AC repair. But finding reliable and trusted providers is difficult because most services operate in an unorganized manner, and they often depend on word of mouth referrals, neighbors and local contacts. And at the same time, many skilled local providers lack digital visibility and are unable to reach a wider customer base. So, to overcome this problem, we developed Connext, which is a smart home service platform that digitally connects customers and nearby service providers. And this platform enables real time interaction through live notifications, GPS tracking. Going to issues, it explains the challenges faced by both customers and providers. Customers face difficulty in locating trusted service providers. There is no single platform where all home services are available. Customers are unsure about service availability and estimated arrival time. Now, from the provider perspective, many local workers don't have a digital platform to showcase their skills. The customer reach is limited only to nearby neighborhoods. They mostly depend on referrals and don't have a structured feedback system. They also lack tools to manage requests, track jobs, and analyze their performance. So, our project aims to solve all these issues through a centralized digital ecosystem. Coming to problem statement, it is to design and implement a digital platform which connects customers with verified providers. It must provide real-time coordination, provider verification, live tracking and structured reviews with proper management. It should also allow both customers and providers to acknowledge service completion and payment within the application itself. To improve reliability, ML techniques are also used. Coming to abstract, it is a hyper-local smart service platform designed to connect customers with verified providers. Unlike existing platforms, it focuses on large cities and registered vendors, but it also supports small neighborhood level service providers. ML is integrated into platform to improve trust and service quality. Coming to literature review, these are the research papers and digital service platforms related to local service management systems. We have analyzed how current systems support service discovery, provider management, and customer interaction and trust mechanisms. From these studies, we identified several limitations like lack of real-time coordination, insufficient support for small local providers, and limited AI integration. So, based on this, we designed our application with enhanced features with real-time communication and live tracking. Coming to the proposed work, it's a centralized smart platform which connects customers with nearby service providers, and we have an admin module which reviews, approves providers before they receive service requests. Customers can create service requests and view nearby providers using interactive map interface. Real and then going to the architecture diagram, we have the front end which is developed using React.js and Tailwind. Backend uses Node.js and Express.js to manage APIs. We have MongoDB as the database for storing users, providers, and service requests. And we have Socket.io for real-time communication, and Mapbox is integrated for GPS tracking. And then finally the ML modules for processing data, then giving predictions, analytics, and detecting frauds, and the overall sentiment analysis. Coming to system requirements, we have used an Intel i5 processor with 8 GB RAM with SSD storage, and then we have used VS Code and GitHub for version control. And then the backend we use Node.js, Express.js, and then JWT for authentication and Multer for file uploads. Coming to modules, we have the user authentication module which helps in the registration and login. We use JWT based role based access control to ensure each one has a particular role. Then customer module which allows users to create service requests and view nearby providers. Coming to service provider module, it enables providers to register, upload verified documents, manage the availability and receive notifications and accept jobs. And then they can also notify the status regularly to the customer and acknowledge payments. Coming to admin module, it allows administrators to verify providers, monitor requests, manage accounts and access analytical dashboard. Then the provider verification module handles document submission, review, approval and rejection processes. Then finally the service request module manages the entire life cycle of a request from creation to provider matching, acceptance, tracking and completion. And then we have real-time job matching where the first provider who accepts the job gets assigned. So basically it's a first come first serve basis. So this prevents double booking. And then we have live tracking module which continuously tracks the GPS location of the customer and uses socket.io with Mapbox. And then we have the review and feedback module where customers can submit ratings and comments after service completion. Then we have the ML and analytical module, ETA prediction, it estimates the arrival time of the provider. Demand forecasting, it tells the overall service demands. And then we have the customer churn, which is the probability of a customer whether he returns or not. And then fraud and anomaly detection. And then this is the Connext homepage, which provides users with an intuitive user-friendly interface for accessing various services. This is the customer login page where customer, once he registers, he logins using his mail and password, and then once he logins he can access. This is the service request page. Here we have the category, description and also the time slot at which these customer wants to book his service, and he can also tell his location. So we have the provider dashboard here. We have three things: available, offline and busy, and the provider can update his status accordingly. And then the incoming request once the customer sends service request. And then we have demand charts. We have the peak booking hours, top places and top services. Then we have the customer retention admin page. It demonstrates customer retention analytics and it analyzes booking history and user behavior to identify customer engagement and retention patterns. These insights help improve customer satisfaction and service quality. Then the fraud and anomaly detection. It demonstrates the fraud and anomaly detection module. ML algorithms identify suspicious activities, unusual booking patterns, and this is the evaluation sheet. So for each electrician and an AC mechanic, we have various evaluation parameters based on which his overall performance has been analyzed. So this is for the carpenter and plumber, and the first one we had it for an AC mechanic. And then these are all the references which we have used for analyzing our project. And then this is our home page. So firstly we come to the admin gives his email and then he gives his password. Once we log in as admin, we can see the admin dashboard. And then this is the customer login. Customer can register, he can give his details, he can also switch language to ensure that other people can also use who don't know English. So this is the login page for the customer. Once he logins, we can see the customer dashboard page, and this is for the service provider, and this is for new service provider registration. So we get the name, email, phone number, password, and then the service category, whether he's a plumber or an AC mechanic, and then the location at which he wants, and also his profile photo and documents. And this is the service provider dashboard page. Now the customer, he creates a new service request. So over here he can give the time slot at which he wants to give his service, and then what plumber or an AC service, and then the description he can give the issue that he has, like tap leakage, and then he can upload it as an image so that the provider has an idea on what the problem is, just for an reference. And then he can give the service location where he wants the service. So basically providers who are within the radius of 5 kilometers, they get notified. So a request has been sent and the request is shown in the provider page. So he views the details and then he accepts the request. Then the status gets updated in the customer page that the request has been accepted by the provider. Then now provider can update his status. He can mark on the way, mark as arrived, mark work started, and request for completion. So every time he updates his status, the time at which he updates this gets shown as a timestamp. This is used for later finding the estimated time arrival and duration prediction. Now once completion request is sent, the provider has marked work as completed, and then the customer confirms whether the service has been completed, and finally he gives the rating out of 5. Once review submitted, it shows that the review has been submitted, and then the provider confirms the payment. So this is the entire request life cycle which happens basically. And now in the admin page we have all the providers. The admin has the option of either approving the provider, rejecting, or deactivating him based on the provider's performance. So the status of each provider gets updated accordingly based on what the admin does. And then this shows the peak booking hours, top places, and top services. And these are all the service requests sent by the customer to the provider. So the admin can view all the requests which is sent by all customers who have logged into the application, and he can view all the status overall. Then coming to the provider analytics, it shows how many reviews each provider has got, average rating, and then the overall sentiment score. And this is the fraud and anomaly detection, which shows the average rating and reviews received. And same customer share means how many times the same customer has booked a particular provider. So if it is high, then it shows that it is there is something wrong. And then fast completion share means to complete a particular service, it must take a particular duration, but it takes very less time. And this is the customer retention, the probability of customer returning to the to our application or not. And this is the demand charts, which shows peak booking hours, top places and top services. Thank you.